Welcome to the deep dive. Today, we're not looking at the latest cloud architecture or some fancy new software. We're going deep into the world of industrial infrastructure.
Very deep. We're looking at a specific device, the NTI VOPEX-4KVIM-A. It's a KVM splitter.
Right, a KVM splitter. And our mission today is really to unpack one question. What kind of high-stakes environment needs 4 different people to use one computer all at the same time?
It's this fascinating paradox, isn't it? It's simple tech for a mission-critical need. The device lets 4 separate keyboards, monitors, and mice, your KVMs, share a single computer.
And just to be clear, this isn't about switching between computers.
No, not at all. It's about splitting the signal from one computer for multiple simultaneous inputs.
Okay, but simultaneous. Why would you need 4 people typing into the same program at once? I mean, my first thought is, why not just use a modern KVM over IP? This feels, I don't know, risky?
It feels risky until you see the context. It's all driven by legacy necessity. So think about a huge control room, maybe a testing facility. You might have 4 operators who all have to confirm separate steps right then and there in a single program. If they had to wait and pass a mouse around, the whole process could fail.
Ah, okay, so you're bypassing network protocols for just raw physical analog input. It's simpler.
Way simpler. And that reliance on simplicity explains the, let's say, vintage connections.
Yeah.
We're talking 15-pin HD for VGA and 6-pin minute-in for PS2.
Classic.
Yeah, because it's built to support old workhorses.
Yeah.
Systems like the RS6000, SGI, HP9000, these are machines that are just too critical or too expensive to upgrade.
They're locked in by certifications or regulations. I get it.
Exactly. And if we follow that thread, the source material points to a really powerful niche use case. Physical separation.
What do you mean by that?
Well, get this. The splitter allows you to access a PC from inside and outside of a clean room.
Oh, wow. Okay, so for like pharmaceutical manufacturing or semiconductor labs.
Precisely. The main computer has to stay inside the sterile zone, but the operator, for obvious reasons, needs to be outside. This little box creates that physical regulated barrier.
That's a fascinating use of hardware to manage compliance. And I see here the specs mention you can extend the connections up to 100 feet.
About 30 meters, yeah.
Yeah.
And that's not an arbitrary number. That's the kind of distance you need to properly separate a critical machine from the operations area for security or, environmental control.
Okay, so let's dig into the resilience factor because that seems to be the real story here.
Yeah.
The specs say it supports a 1920 by 1200 resolution with 150 millihertz bandwidth. That's pretty robust for an analog signal.
It is. The signal integrity is solid. But the real metric, the one that tells you everything you need to know, is the MTBF.
The mean time between failures.
Right. And for this 4-port model, the MTBF is 79,417 hours.
79,000 hours. That's almost 9 years.
9 years of continuous 247 operation before you can even expect a failure. That's not disposable tech, that's infrastructure.
And it's clearly built for a certain kind of buyer. I'm seeing it's TAA compliant, which, for anyone who doesn't know, is the Trade Agreements Act. That means it's made in the U.S. or an approved country, which is a must-have for a lot of secure government contracts.
So you put it all together, the legacy support, the clean room application, the regulatory compliance, it paints a clear picture.
It does.
This is a device that proves that when data integrity and environmental control are paramount, sometimes the rock-solid reliability of old-school analog just wins. It beats modern digital complexity.
So here's a thought to leave you with. Given that level of specified resilience, that's 79,417 hours, what other seemingly simple legacy devices might be silently running our most crucial systems right now, with decades of operational life still ahead of them? Something to think about when you look at all our modern network architecture.